Hello everyone. We are starting our free open lecture on our Discord. If you are a viewer and want to ask questions online and get answers, then join our lectures. You can find the link to Discord in our Telegram channel. So, we will write binary search in the same way. In this particular case, I will specifically be writing in the Python programming language, and I can also write in C++, but it simply takes a bit longer to complete. So, we have some function. This is our main, and here we will write some binary search. It will be named something like that. Just like in the example, binary search, and choose. For now, I don't know what variations and values I will pass to it. We will send something to this binary search function. We can send 3 numbers A, B, and C to it. They are already sorted in order. You can also send a list. It depends on what is more convenient for you to implement this task. Next, we specifically specify that our left boundary is equal to 0 and our right boundary is equal to A1, because we will be searching through it, because the rule of existence states that we will subtract at least 1 unit. Therefore, we equate A1 here as the smallest element. Next, we write the while loop in the same way, where L is less than or equal to R. We calculate the central value as L plus R divided by 2, and then we compare, that is, if we have the value in the center, that is, the one we subtract, the central value is the one we subtract, that is, accordingly, how many seconds have passed. If we have a minus the middle equal to B minus the middle plus C minus the middle, that is, if we simplify this, we can write B plus C minus 2 times the middle. What do we get? Or, if we simplify this further, we can subtract the middle here and subtract the multiplication by 2 here. I'll do it right away for convenience. So, if they are equal, I immediately return the middle element. Accordingly, in the other case, that is, if A is less than B plus C minus the middle, then in this case, I move the right boundary. That is, our left boundary does not exist, meaning it is still less. We have existence, so in this case, where should I move? We can consider this again on our coordinate line. We have some 0 element, and we have our 8. Let me draw this again. We calculate the center here. In this case, it will immediately be 3. That is, it will be 0. But here we will have the last 7, which we take because we take 8 minus 1, so we take 7 as the right boundary. This is the left, and this is the right.
Want to become a great programmer? Subscribe to our Telegram channel.
And accordingly, we understand that this triplet is present, meaning we subtract the triplet from some element, and here we will write it out with the example of 8. That is, 8 minus 3, some sign. An unclear comparison is denoted by such a sign. It turns out that B plus C, more precisely in this case, it will not be 8 here, but the largest number, that is, we will have 14 minus 3, and we will compare it with A plus B. So, this is not quite correctly written here, meaning we will compare C as the largest with a plus B minus the middle. And accordingly, here we will have 8 plus 12 minus our middle element 3. So, in this case, we get 11, which will be less than 8 plus 12 minus 3. We get 17, so the triangle exists in this case. And the question is, where should we move? And we need to move towards non-existence. That is, we want to move to the right in this case. So in this case, after such a condition, we move the right, or rather the left. We move to middle plus 1. Accordingly, in the remaining case, I will write it down for the condition to make everything clear. If we have more, it can be written simply using else, because these are all the cases, either less, more, or equal. We don't have any other options. Accordingly, this is the condition. If A is greater, then in this case we will move the left boundary because in fact it already does not exist. For example, we might encounter the rules of non-existence. For instance, it is located like this, and we need to move it here. That is, we are not looking for the first non-existence here, because we need the minimum. In this case, we move the right boundary by minus 1. All we do then is return the element immediately. Since the function is sequential, the values themselves do not all increase by 1. There are no missing values, meaning, for example, if we want to find a 3, there might not be a 3 in the array. In this case, all elements will be present, so there will be no comparison and return of -1. That is, in this case, we return the element L, which is simply the left index. Now we will write the reading. We have A, which is equal to int input. Similarly, we have B. We have some element C, which I will immediately put into a list for convenience. Accordingly, I will sort this list in ascending order. It will be sorted immediately, and in ABC I will assign a 0, or rather some list 0, list 1 and list 2. That is, after this point in time, I return what I return, the index that we need. That is to say, I can write down explicitly that ultimately the result will be equal to a binary search of A, B, and C, where both B and C, after undergoing this sorting process, will be arranged in ascending order. It doesn't really matter much at all to us whether they should be in exactly the same order as when we initially read them, because essentially, we have complete freedom here and can do anything whatsoever with them. And then finally, we print out our result, because it's necessary for us to compare it directly with the maximum element present. So now let's run through this entire process once more and test everything thoroughly, just so see if indeed we've done everything correctly or not. According to given data provided earlier on, the answer turns out being 4, which seems quite evidently correct. Therefore, logically speaking, we are already able to send off code for further testing purposes. In conclusion, therefore, in summary, in essence, we reviewed every single thing meticulously step by step, rewrote each part into coherent code, formulating all thoughts clearly, because these steps give reliable results, and thus got an accurate answer. Now let's move on to the next task.
Want to become a great programmer? Subscribe to our Telegram channel.